Triple integrals. Triple integrals can be used to find volume, just like the double integral, and to find mass. When the volume of the region we're interested in has variable density. In this way, triple integrals let us do more than we were able to do with double integrals. So meaning to say that for triple integral, we are integrating a multivariable function for density function x, y, and z for the volume B, which is defined for x on the interval a and b, and for y on the interval c and d, and for 2 on the interval rs. Volume. Volume is a scalar quantity expressing the amount of the three-dimensional space enclosed by a closed surface. For example, the space that a substance, solid, liquid, gas, or plasma, or 3D shape occupies or contains a volume is often quantified numerically using the SI derived unit, the cubic meter.
Volume using triple integrals. The volume of a closed solid region is given by the volume is equal to the triple integral on the region D. The differential V is equal to the dz, dy, and dx. In the given example, use a triple integral to find the volume of a solid tetrahedron enclosed by 2x plus y plus z equals 4 coordinate planes. Tetrahedron is just like a pyramid. It is like a three-dimensional triangle. Find the volume of the solid tetrahedron. In order to find the limit of integration of x, y, and z, we will use some concept of algebra. The lowest value will obtain 0. The limit of integration for x, we will use 0 as the value of y and z to come up with the value of x, which is from 0 to 2. The limit of integration for y, you will use the additional property of equality to come up with the value of y, which is from 0 to 4 minus 2x. The limit of integration for z is similar to the process using addition property of equality. The value of z is from 0 to 4 minus 2x minus y. Now that we have the limit of integration, we just need to figure out our order of integration by looking at the variable involved. There are two variables involved in z. There is one variable involved in y, and there is no variable involved in x. Order of integration should be in descending order of the number of variables involved in the limit of integration. All we need to do now is set up our integrals. So we got a triple integral here. The order of our integration is dz, dy, and dx. Because you always starts with the inside and work it with the outside, that's why the z is the first, y is the second, and x is the third. For z, it is from 0 to 4 minus 2x minus y. For y, it is from 0 to 4 minus 2x. And for x, it is from 0 to 2. It is not just dz, dy, and dx, it's really 1 times dz, dy, and dx. That's how we set up our integral.
Let's integrate with respect to c. It is from 0 to 4 minus 2x y. Then, plug in 4 minus 2x minus y. Since the lower limit is 0, so we don't have to write it and leave dy and dx. And we're gonna simplify and move on to integrate with respect to y. So we have 4y minus 2xy minus 1 half x squared. So we need to substitute the 4 minus 2x to y. So we have 4 times 4 minus 2x minus 2x times 4 minus 2x, then minus 1 half times 4 minus 2x squared. So we're gonna simplify. So 4 times 4 is 16. Then 4 times 2x is 8x minus 8x plus 4 2x minus x squared, and we get 16 minus 16x to 4x squared, and we leave the dx. Then combine like terms. So we have 16 minus 16x plus 4x squared minus 8 plus 8x minus 2x squared, then dx. So we then simplify, then we get 16 minus 8 minus 16x plus 8x plus 4x squared minus 2x squared, and dx. Then we will get the result of 8 minus 8x plus 2x squared, then dx. Then we're gonna simplify and integrate with respect to x. So we have 8x minus 4x squared plus 2/3 x squared. So we're gonna substitute the value of x to 2. So we're gonna come up to 16 minus 16 plus 16 over 3. Therefore, our volume will be 16 over 3. That's it.